In the previous episode, we deployed a complete real-world application on Kubernetes. The application worked, users could access it. Data was stored in PostgreSQL. Everything was functional, but working is not the same as production ready. Today, we'll improve that application using Kubernetes Best Practices. Production environments introduce new challenges. Applications consume CPU and memory. Pods crash. Services start before applications are ready, and troubleshooting becomes more difficult. Kubernetes provides features to solve those problems. Today, we'll implement some of the most important ones. We'll improve the Students Portal application we built in EP14. Specifically, we'll add labels, resource requests, resource limits, Liveness Probes, Readiness Probes, and Startup Probes. These are common configurations you'll find in real production deployments. Kubernetes provides 3 different types of probes. Liveness probes determine whether an application is alive. Readiness probes determine whether an application is ready to receive traffic. Startup probes help Kubernetes understand when a slow application has finished starting. We'll implement all 3 today. Enough theory, let's make our application production ready. Before we start making changes, let's create a dedicated folder for this episode. Just like we did in the previous labs, we'll build everything step by step and keep every stage of the deployment. Let's start with a very simple deployment. The application works. Kubernetes can schedule it, users can access it, but there is very little information about the workload itself. That's where labels become important. Labels are simple key value pairs attached to Kubernetes objects. They help us organize resources, filter workloads, and identify applications running inside the cluster. In production environments, labels become essential for operations and monitoring. Perfect. We can now see our labels attached to the pod. Kubernetes allows us to filter resources using those labels. Labels may look simple, but they are one of the foundations of Kubernetes. Services, deployments, and many other Kubernetes resources rely on labels to identify and select workloads. Next, let's improve how Kubernetes manages CPU and memory by adding resource requests and limits. Our application is now properly labeled, but Kubernetes still doesn't know how much CPU or memory this application needs. That's a problem because the scheduler uses resource information to decide where pods should run. Let's fix that by adding requests and limits. Resource requests define the minimum resources required by the application. Kubernetes uses these values when scheduling pods. Limits define the maximum amount of resources the pod can consume. This prevents a single application from impacting other workloads running on the cluster. Kubernetes is recreating the pod with the new configuration. Let's verify that the resources have been applied. Kubernetes now knows exactly how many resources this application requires. Requests help Kubernetes schedule workloads. Limits protect the cluster from excessive resource consumption. These settings are considered a fundamental best practice in production environments. Labels help us organize workloads. Resource requests and limits help us manage cluster resources. Next, we'll teach Kubernetes how to determine when an application is ready to receive traffic using Readiness Probes. Our application now has labels. It also has CPU and memory requirements, but Kubernetes still doesn't know when the application is actually ready to receive traffic. That's where Readiness Probes come in. A readiness probe allows Kubernetes to check whether an application is ready before sending requests to it. In this example, Kubernetes will perform an HTTP request against the application. If the application responds successfully, the pod becomes ready. Only then will Kubernetes allow traffic to reach it. Notice the ready column. Kubernetes is now checking the readiness probe before marking the pod as available. If the probe fails, traffic will not be sent to the pod. We can see that the readiness probe is now part of the pod configuration. This is extremely important in production because applications often need time to initialize before they can safely receive requests. Kubernetes waits for pods to become ready before considering the deployment healthy. Readiness probes control traffic. They determine when an application is ready to receive requests. Next, we'll look at Liveness Probes, which help Kubernetes detect and recover from unhealthy applications. Readiness Probes control traffic. Liveness Probes have a different responsibility. They determine whether the application is still alive. If Kubernetes detects that the application has become unhealthy, it can automatically restart the container. We can now see both probes configured. The Readiness Probe controls when traffic can reach the application. The Liveness Probe helps Kubernetes recover automatically from failures. Together, they significantly improve application reliability. We now have Readiness and Liveness Probes, but some applications take time to start. Databases, Java applications, Spring Boot services, and many enterprise workloads may need several seconds or even minutes before becoming available. That's where startup probes become useful. Startup probes tell Kubernetes to be patient during application startup. While the startup probe is running, Kubernetes won't evaluate the Liveness probe. This prevents applications from being restarted before they have a chance to fully initialize. We now have all three Kubernetes probes configured. Readiness determines when traffic can reach the application. Liveness determines when Kubernetes should restart the application. Startup protects slow starting applications during initialization. Let's take one final look at our deployment. We started with a very simple application, and step by step, we transformed it into a more production-ready deployment. Our application still does exactly the same thing, but now Kubernetes has much more information about how to manage it. We can organize it using labels, control resource consumption with requests and limits, and monitor application health using Readiness, Liveness, and Startup Probes. These are some of the most common Kubernetes best practices you'll find in real production environments. Today we transformed a basic deployment into a production-ready deployment. We added labels, resource requests, resource limits, and health probes. In the next episode, we'll take the Students Portal application we built earlier in the series and package everything into a reusable Helm chart. Instead of managing multiple YAML files, we'll deploy the entire application using a single Helm command. See you in episode 15. Convert our application into a Helm chart.